the first thing, I just want to review solving quadratic equations, just list them one more time. So solving quadratic equations. First method, factoring. Done and over with a long time ago. I'm going to put in parentheses, not always possible. It's not always possible. If the polynomial is factorable, then I can factor and solve the equation, but there is no guarantee. The second method is taking square roots. This is always possible, and it requires some work. We have not talked about it yet. In a minute. 3, completing the square. Always possible. Requires some work. We haven't talked about it. We will in a minute. However, I'm going to write a note here. Used to solve equations, quadratic equations, only by force. Will I ever use it? No. No, it's used for something else. That's why we study it. But no. But if you force me and I have no choice and the problem is asking me to, I will. Otherwise, I'll stay away from it as far away as possible because it's used for something else. It's a very good method. But I will never, ever, ever use it unless you force me to. Okay, number 4, quadratic formula. So this, I would use the first one, factoring, if it does not require 5 minutes. If it requires 20 seconds, I will use factoring. I will use this immediately because this always works. If it takes too long, if it takes more than 20 seconds to factor, forget it. I'm going to use the quadratic formula. Okay. Taking square roots. When will I use taking square roots? Only when it's set up that way. Only if it is set up already. If it is not set up so that taking square roots is effortless, no, because then I have to complete the square in order to use the taking square roots. So number 1, factoring if it works fast. Quadratic formula is my next choice, yes. Taking square roots if it's already set up that way, and I will show you in a minute how. Completing the square, never. No, because I have other methods that are very fast. But if you force me and you say that this problem has to be solved in that way, then I have no choice. So this method is very important for something else later in another course. Okay, so I'm going to explain taking square roots first. So number 2, taking square roots. This is really nice. At some point in time, we solved the equation, if you remember, x squared minus 4 equals 0. And you said, yeah, piece of cake, factor, and find the solutions. And it's done. What if I don't use factoring in this case? What if I do this instead? I move 4 to the other side. Remember, it's quadratic. I still have to get two solutions. I must get two solutions. And now I take the square root. And remember what we talked about the square of x squared if we don't know x. So what does the square root of x squared equal to if we don't know if x is positive, it can be negative, la la la.
Absolute x.
Yes. We have to use the absolute value of x, and the square root of 4 is always 2. But this equation has two solutions. X equals positive or negative 2. Because if I plug in 2 here, the absolute value is 2. If I plug in negative 2 here, the absolute value of negative 2 is 2. This is the method of taking square roots. Very easy, very nice, if it is set up that way. So here's another example. What if I have x plus 2, everything squared equals 16? Yay, it is set up that way. I will take the square root directly from both sides. I will write x plus 2 and I will skip this step. And I will directly go to plus or minus 4. Please remember the plus or minus do not come from the square root of 16. They come from the absolute value on the left-hand side. Please do not ever assume that the square root of 16 is plus or minus 4 because it's not. The plus or minus come from the other side, from the absolute value. And then I move 2. And now I have to separate them. Negative 2 plus 4 and negative 2 minus 4. So again, factoring, if it takes 20 seconds or less. Quadratic formula, always possible. Taking square roots, only if it's effortless. If I have 10 steps to perform to get it here, no. Use the quadratic formula. So that's taking square. Yes, Sarah?
Could you do one more example of taking the square root?
Sure. Here's another one. So let's say 2 x plus 1 squared minus 4 equals 0. So this is not exactly set up, but it's a very easy step to set it up. I will subtract 4 and divide by 2. So I have x plus 1 squared equals 2. It took almost no effort to put it or set it up for the square root process. So then I have x plus 1 equals plus or minus the square root of 2. The plus or minus do not come from the right-hand side, but they come from the skipped step because we're lazy. So negative 1 plus or minus the square root of 2, and this is the final answer. Notice that I took the number and I put it in front. Do not separate plus or minus from the square root of 2. Do not insert 1 in front of the square root of 2 and put plus or minus in. No. This is together. These two are together. So this is very elegant. It's a nice method, only if it's effortless. If it takes 5 minutes to set it up like this, forget it. It's not worth it. It's not set up for taking square roots. I don't need it. And finally, we get to the third method, completing the square, which again, I say, never, ever, ever on solving quadratic equations unless I have no choice. Okay, so here's an example. Allow me 1 second to check if I can get rid of these videos. Yes, I can. 1 more second. Allow me to delete them. 1, 2, 3, 4, 5, and 6. So I don't have surprises later. It tells me that it cannot record anymore. Okay, so the last method, complete the square. It's a method that can be applied to solving quadratic equations, but it's used for something else. Very useful method, but no, not for this. Okay, so let's suppose I have the following situation. X squared plus 4x minus 3 equals 0. And let's say that you force me to use the completing the square method. Okay. First step, I will move 3 to the other side. Does this have to be the first step? Not necessarily, but I will do that. Then I start the procedure. The procedure states middle coefficient. Number 1. It's it's arranged in descending order. Therefore, the middle coefficient is 4. Step number 2. Divide 4 by 2, and I get 2. Step number 3. Square number from the previous step. Get 4. Step number 4. Add 4 to both sides. I'll explain why the procedure in a moment. Let's use the procedure once to see what we get, and then I'll explain why we have the steps we have. One more time. I moved the free term to the other side, and I left the first 2 terms untouched. In step 1, I identify the middle coefficient. In step 2, I divide this by 2. Then I square the result from step 2. I get 4, and then I add 4 to both sides. It has to be to both sides, otherwise I change the problem. So the new equation becomes x squared plus 4x plus 4 equals 3 plus 4. From the factoring on test 3, that's why test 3 is so huge, I need to remember how to factor this. If I don't, I'm stuck.
4 and 1.
Say it again.
4 and 1.
Careful. Remember, it's a
X plus
special product. So this is x plus 2, everything squared. Remember?
Right.
Remember, we always cover when the first term and the last term are perfect squares. We always assume this, but we have to check the middle term. 2 times the first times the second. Oh, okay. Now I have to use the previous method. So not only this is a super cumbersome method for quadratic equations, but I cannot even get the answer before I use taking square roots. So what's the point? Yes, there is a point, but this is useful for something else. Not for this. As you noticed, this alone does not do the job. If I don't remember this, I get stuck. Okay, I completed the square. Now what? But it's a very important method for something else in math. That's why we study it here. Is it applicable to quadratic equations? Sort of. Should I ever use it? No. Unless I have no choice. So then I have x plus 2. If I forget plus or minus, I'm not getting the solutions. I'm getting something, but not the solutions. Again, remember, the square root of 7 is not plus or minus the square root of 7. The plus or minus come from the absolute value on x plus 2. But we lazily, skip that step. And I move 2, but I have to move it in front of plus or minus. And I got the solutions. This is it. That's the final answer. Okay, now why we did what we did. In order to change this into a perfect square, I need to figure out what is this number that matches this and this to create the perfect square. That's why I took this number. I divided by 2 because remember when I determined the middle term here, It's 2 times the first times the second. So to determine this number, I had to divide 4 by 2. And then why did I have to square it? Because it has to be a perfect square to get this. So first I take the middle term, strike that, the middle coefficient, I divide it by 2, then I have to square it, and now I know that this can be replaced by this. I have to add 4 to both sides. If I add it only here, the whole thing is a mess. I have to add it to both sides so I don't change the equation. I combine like terms, and now I can take the square root because I'm using a totally different method, without which completing the square does not do the job.
Will you always divide the middle term by 2?
Because that's the middle term, how we get it here, 2 times the first times the second. Yep, that's the procedure. And that's it. Let's look at different problems now and see how we handle them.
Wait, is this 8.4 or 8.5?
6. 8.6. We did 8.7 quadratic formula. We're going to look at more examples from there. And this is 8.6. And we did the 8.5 last time. So from here, let's choose whatever we need. We're going to go step by step, and then we'll go back to quadratic formula to see what they want in there. Okay. Okay, and you let me know. Solve the equation taking the square root property.
Plus minus 7.
Exactly. X equals plus or minus 7. That's it. You're taking the square root from both sides. So x equals plus or minus 7. So the x squared equals 49. We take the square root. X equals plus or minus 7. Done. Same thing here, but we have to simplify it. Because 175 is not a perfect square, we have to take it easy here. So I do apply the square root because it's already set up. But the square root of 175 is, I'm sorry?
5 to the square root of 7, so plus or minus 5 to the square root of 7.
So you mean 5 times the square root of 7.
Yeah.
Perfect. So the square root of 175 is the square root of 25 times 7. That's why the square root of 25 is 5, and the square root of 7 stays as the square root of 7. Very good. Any questions on this problem? Don't be shy, please. Anything? Okay, moving on. Good. X squared equals 3 over 16. The same thing. It's already set up. So we can take the square root from both sides, and do not forget plus or minus. If we forget plus or minus, we're not getting the solutions. We are getting part of the solutions, and we cannot get full credit.
It would be plus or minus the square root of 3 divided by 4.
Indeed. That's all there is to it. Very good. Any questions? Anybody?
Yeah, I mean, I didn't think of the absolute value and then converting it to plus or minus. That makes more sense to me now.
Yes. So the correct answer is this. So if I have x squared equals 4, I take the square root. This is the absolute value. Please always remember the square root of x squared does not equal x. The square root of x squared equals the absolute value of x if x is in negative infinity to infinity. Unless somebody says x is only positive. So you have to write this. And this gives us 2. But this equation has two equations hidden in it. One equation is x equals 2, and the other equation is x equals negative 2. So the plus and minus come from here, not from here. But we omit this step just because we're lazy, and we are jumping directly. We jump directly from the square root of x squared equals from x squared equals 4 directly to x equals plus or minus 2. But this is the intermediate step. But the problem is that many students start to believe, because we skip this step, they start to believe that the square root of 4 is plus or minus 2, which is absolutely incorrect. The square root of 4 is not negative 2. The square root of 4 is only 2. Good. Now x squared plus 4 equals 79. Although this is not set up like that, it's effortless to set it up for applying the method of taking square roots.
Would be x equals plus or minus 5 t squared is 3.
But first of all, we have to write x squared equals 75 because 79 minus 4. So we have to write that first. Good. And then after that, we take the square root from both sides. And we have to simplify the square root of 75, or change the square root of 75 into the square root of 25 times 3.
You factor out the 25.
We take the square root of 25, so then x equals plus or minus 5, the square root of 3.